At 0847 hours, 4 Russian nuclear-capable bombers were heading straight for the Norwegian Sea with an escort of 2 fighters. While everything seemed routine for the Russian pilots, this would all change in a matter of seconds. The scramble order hit the Evans Air Station at 0851. 2 F-35s from 332 Squadron were wheels up by 0855, climbing through Arctic sky toward an intercept point 380 kilometers northeast. But these pilots weren't flying a standard intercept. They swung south first, then curved wide over the Norwegian Sea before turning northeast, approaching from behind the Russian formation rather than head-on. That routing adds 12 minutes to intercept time, and it was worth every second. A head-on approach creates 700 knots of closure, less than 20 seconds from visual range to merge. Stern approach drops that to 400 knots, giving pilots a full 5 minutes to assess the formation before contact. But the real advantage is geometry. The NALA radar you see on these bombers points forward in a 120-degree cone, scanning for threats ahead. Approaching from the 6 o'clock means approaching from the pilot's blind spot, the one place Russian radar physically cannot look without the entire aircraft turning around. By positioning behind and above, the Norwegians created what fighter pilots call a perch, altitude advantage convertible to speed. If the Russians dove to escape, the F-35s would convert altitude to velocity and close the gap. If they climbed, they'd lose airspeed and become easier targets. If they accelerated, the F-35s had fuel margin to match. Every escape vector led deeper into the trap. Inside the bare cockpits, SPO-15 Burza threat receivers showed empty sky. NALA radar sweeping the forward hemisphere found nothing. As far as Russian instruments knew, they owned the airspace. The pilots settled into cruise, watching instruments that promised safety for 7 hours of routine patrol ahead. Their instruments were lying, and in a few minutes they'd discovered just how completely they'd been fooled. At 0903, the F-35s reached intercept position, 80 kilometers behind the Russian formation, 3,000 meters above, completely undetected. The Norwegian pilots hadn't activated their radars, didn't need to. Through their helmet visors, they were already watching 8 exhaust plumes burn against the Arctic cold, targeting computers building perfect firing solutions while broadcasting nothing. If this were a shooting war, every Russian aircraft in that formation would be finished before NATO's morning coffee got cold. That's because the ASQ-239 distributed aperture system had been tracking them since 200 kilometers out. 6 infrared cameras wrapped the F-35, 2 on top, 2 on bottom, 1 on each side, feeding into a computer that stitches them into a single spherical image projected directly onto the pilot's helmet visor. Look down through your ejection seat, see targets below. Look over your shoulder, see what's behind. The aircraft becomes a glass cockpit in the most literal sense. The pilot sees through the airframe as if it doesn't exist. It's the difference between looking through a keyhole and having eyes in every wall of the room. Against the Tu-95s, DOS barely had to work. Those NK-12 engines are the most powerful turboprops ever built. 15,000 shaft horsepower each, driving contra-rotating propellers with blade tips that break the sound barrier. All that power generates heat. If you look at the thermal display, each engine glows at 400 degrees Celsius against a minus 30-degree sky. A 430-degree differential turns every bear into a bonfire visible from 200 kilometers. With 4 engines per bomber, that's 8 signal fires announcing Russian position to anyone with infrared sensors. The Bears weren't flying a patrol, they were flying a please track me parade. The 2 F-35s split into combat spread, 2-kilometer lateral separation. lead at 30,000 feet, wingman offset south at 32,000, not random positioning. Lead's cameras track the bombers from one angle. Wingman's cameras capture them from a different angle. MATL, the multifunction advanced data link, fused both pictures in real time, sharing targeting data through directional transmissions that Russian receivers couldn't detect. Each pilot saw a composite image built from 12 cameras. Twice the coverage, twice the accuracy, zero emissions. The Su-33 escorts kept checking their 6. That instinctive, over-the-shoulder glance fighter pilots have made since 1915. Their Nala radar showed nothing. Threat receivers showed nothing. But 60 years of Soviet aviator instincts were screaming that something was wrong. The instincts were right. The equipment was just too old to agree with them. The escorts flew classic Soviet doctrine, 4 pairs weaving around the bombers to screen the threat axis. Good tactics if you know where the threats come from. They were watching from the forward hemisphere, where enemies had always appeared. The F-35s were behind them, invisible, building targeting solutions on the escorts themselves. If the Su-33 somehow detected the F-35s and turned to engage, they'd face a beam defense. F-35s turning perpendicular to put closure rate to 0. This is because pulse Doppler radar works by measuring velocity. It filters out slow-moving objects like ground clutter by ignoring anything not approaching fast. Turn perpendicular, your closure rate drops to near 0, and the radar's zone filtering make you disappear into the noise. Meanwhile, the second F-35 circles to the engaging escort's 6 o'clock. The Russian pilot chasing one ghost finds another ghost on his tail. The F-35's fire control computers calculated AM-120D solutions, radar-guided missiles that fly at Mach 4, track autonomously in the terminal phase, and carry fragmentation warheads that shred aircraft from 50 meters away. The Norwegians decided to announce themselves instead. What happened next would turn Russian confidence into confusion, and confusion into something close to panic. At 09:11, the lead Norwegian activated his radar for exactly 2 seconds. Inside the bare cockpits, the morning went from routine to terrifying. SPO-15 threat receivers erupted, warning tones, flashing lights, the unmistakable signature of targeting radar. Every crewman knew that sound. Someone had them locked. Someone could take them out. Hands tightened on armrests, eyes snapped to threat displays. Then nothing. Radar vanished. Warnings stopped. Displays showed empty sky. 2 seconds was enough. That's because the APG-81 radar you see here on the F-35 uses 1,200 individual transmit-receive modules arranged in a flat panel, an active electronically scanned array. Traditional radar rotates a mechanical dish to sweep the sky, taking 2.5 seconds per scan. AESA steers electronically by adjusting the phase relationship between modules, essentially pointing the beam by making some modules transmit microseconds before others. The result? The beam moves at the speed of electricity, repositioning in microseconds instead of seconds. Focus on 1,200 modules on a single point. Get precise range, velocity, and heading, then shut down before anyone can locate you. 2 seconds gave the Norwegians targeting-grade data on every aircraft in the formation. One burst, that's all it takes in a shooting war. The Su-33 pilots reacted on instinct. Hard turns into the threat axis, radars to maximum power, gardenia jamming pods spooling up against whatever had just painted them. They searched with equipment that was relevant when disco was cool. Mechanical dishes sweeping left to right, 2.5 seconds per scan, looking for something that had already vanished. Nothing, nothing, nothing. That's because the F-35's radar cross-section measures 0.005 square meters, roughly a golf ball. That's not an accident.
The airframe is shaped so radar energy scatters away from the receiver rather than bouncing back. Edges are angled. Surfaces are coated with radar-absorbent material. The engine intake is curved to hide the compressor face, one of the most reflective parts of any aircraft. The Russian Nala radar was designed to find carrier groups, 100,000-ton warships throwing massive returns across kilometers of ocean. Asking it to find a golf ball at 80 kilometers is like trying to find a regular non-influencer at Coachella. The Russian radar kept sweeping. The radar kept finding nothing. The gardenia pods pumped jamming into empty air, burning electricity against missiles that didn't exist, protecting the formation against threats that had already gone